Hello. Thank you for attending this session about how BBVA is avoiding data filtration on AWS. This is Jose. I'm a global solution architect within the AWS Financial Services Organization. And today with me is Luis Garcia. Luis Garcia is the global cloud security leader in BBVA. Okay. So, but first of all, before Luis told us about the platform and the solution, let me talk about some additional challenges that the financial services customer are facing. So, financial services customer, as you probably know, is a highly regulated environment, such as healthcare or government. BBVA also have multiple locations, so they need to be compliant with the several regulatory guidelines. Besides of that, those guidelines are continuously changing, in continuous evolution. So today we are going to talk about how they avoid things like data breaches. Okay, data breaches that can result in regulatory fines, legal cost, or even in reputational damage. And I will be very quick in refreshing about Amazon AppStream service because Amazon AppStream service is a key piece for BBVA for this architecture. Very basic. So you deploy the native application with whatever compute, graph, data that it's need. Amazon AppStream will enable that application in a secure pixel stream to the end users, and those end users will connect to the application via web browser or via Amazon AppStream native client. It's basic, but it's helping security teams to secure that sensible, that important business and customer data. Very few important points about security. All the application data is on AWS. Only the encrypt pixels, the encrypt display, keyboard, mouse are traversed to the remoting protocols. Policy controls are available. Those policy controls are used to restrict the users to do things like copy and paste information, download, upload information through the Amazon AppStream. It's important also to mention that it supports multi-factor authentication. Most of the most important or most popular identity providers to ensure that the strong authentication measures. And finally, it also it's integrated or supports also AWS VPC interface endpoint to allow that all the traffic is through the AWS backbone and it's not going through the internet. But just before to start the presentation from Luis and from BBVA, just few concepts that I want to be clear for understanding the presentation. So first is the image builder. The image builder is thinks about a virtual machine powered by Linux or Windows Server, where you install the application, configure your application, and you create an image, which is going to be deployed after that in a fleet. A fleet is several streaming instances that are providing that application to your end users. It's important to mention also that the images are centrally managed. That means that when you need to upgrade your application, just upgrade the image, and at that time you will have the application upgraded for all of your end users, and they don't need to do anything else. Okay. And the last concept is stack. So once you have your fleet that you configure also, because the fleet, as I mentioned, is a group of streaming instances, okay? And based on your requirements, you can create a policy to scale. If you need more streaming instances, or if you need less streaming instances, you can also configure that. And stack gives you the ability to control that user task that I mentioned before. I don't want that my users can copy-paste information to another application, things like that. Okay, that's a stack. And just two more important things. I also mentioned about the data. Data is always, application data and customer data are always on AWS. Okay, you only transmit encrypt pixels, okay, to the end users. And second thing is, customer is not in charge of setup or manage the data plane or control plane. Okay, everything is on AWS. Saying that, Luis is here to talk us about how are they avoiding to do data filtration. But Luis, can you help us to understand what's BBVA?
Yeah, sure. For those of you who don't know BBVA, I think an introduction is in order. BBVA is a Spanish bank with a strong global presence. It is present in more than 25 countries as of now. We are more than 120,000 employees all over the world. And currently we've got over 70 million of active customers, out of which more than 50 million are digital customers. And because of this, we believe our digital channels are a priority. Our purpose is to bring the edge of opportunity to everyone. And finally, I would like to give you just one economic number to show you how big BBVA is. The total assets of BBVA are valued on over 800 billion euros. You know, the history of BBVA along with AWS is relatively long. Jose, can you tell us more about this history?
Yeah, so the journey of BBVA on AWS started long time ago. Okay, so they start to test AWS in 2012. Okay, it's a lot of years ago. But the first production workloads they start to put on the AWS on 2016. In 2016, so things start to grow a lot of accounts, a lot of workloads, and in 2018 we said, okay, wait, let's stop. Let's try to figure out a better way to governance everything on AWS, and after that keep it running. So we create a joint team between BBVA engineering team and AWS account team plus service team, and create a custom landing zone for them called VDC that we are going to talk later. This custom landing zone help us to in 2019 to start the global expansion around the globe. Okay, global expansion that it was accelerated by the COVID-19 with a project that Luis will explain later with AppStream. Just to finish, last year BBVA started to use their third region, the region of Spain. Why? To try to put AWS near their customers in EMEA and near their employees. And now BBVA published 2 years ago that they are moving all the data platform that they have on premises to AWS. So this project is already running on AWS, and first users are being created. All the data platform of BBVA running on AWS and relying on AWS managed services. But I don't know, Luis, can you offer us more numbers about this?
Sure. As you know, we are present in several countries, and because of legal and billing requirements, we are forced to have several AWS organizations, one per country. And currently we've got 12 AWS organizations. Along these 12 AWS organizations, we've got right now almost 600 AWS accounts. And because of the recent data platform migration to AWS, we expect to grow up to 1,000 within the next 12 months. In terms of regions, as you will sure know, we aim to be as close as possible to our customers and our internal employees and users, right? And in order to accomplish this in the best way, what we do is to use the AWS regions that AWS offers to us. And in our case, the regions that we are currently using are North Virginia, Ireland, and more recently, the new Spanish region. During the next year, we are expecting the release of the New Mexico region, and hopefully we will add this region into this list. And next, I would like to give you a number that I think represents very well the diversity that we try to employ at BBVA. We are using over 100 AWS services. As you may see, within these services are not the typical infrastructure as a service and computing services. We try to explore new technologies and use more recent and new services like, for example, big data services, artificial intelligence service, and IoT services. And as you know, I'm part of the global cloud security team, and one of our main duties is to define our cloud security posture. And the way we are trying to define this security posture in AWS is by defining something that we call security policies. And you'll be wondering, what is a security policy for us? A security policy for us is just a set of best practices and requirements in terms of security. And we define this security policy for each cloud service, in this case, AWS services. These services describe how the users within BBVA have to use in order to use a cloud service, okay? And by using these security policies, they help us to identify things that we have to control. And by defining these controls, we are able to create, to develop remediations or enforcement via service control policies that allows us to reduce the risk of data exfiltration. And to finish with this, I would like to point out that for us, it is harder to scale in the management of the security of the AWS organizations, the accounts, and the regions, rather than the workloads that you may see on the screen. It is much harder for us. And what we are trying to ease this management is something that Jose has already mentioned, that is the BBVA landing zone. Jose, can you tell us more about this?
Yeah, because as I mentioned before, AWS at a scale, you need something else, right? So you need a framework to meet BBVA needs the framework to meet those security needs while maintaining also the ability to scale, okay, and not to penalize the pace of innovation of the project teams, okay. So they create multi-account environments. Imagine that this is only one of the BDCs, but Luis mentioned that they have 12 organizations. So this should be very. This should be very automated, and they are using CloudFormation for that. Okay, this is based in AWS organization, as I mentioned, with service control policies and boundaries to restrict the users for using non-validated services, regions, and some tasks that they don't want to allow the users to do. Every account is created at the same way with account baseline that is based in the requirements of the project. Security architecture team is centrally managed. All the security in all of the accounts. All the accounts send information and logs, metrics to Luis team accounts. And the network, very strict network baseline. Imagine that it's not only that they have 12 VPCs, but they need to connect with two main data centers. Okay, one in EMEA, one America, but also with other cloud providers. So it's a very complex network topology that Luis will explain later also. They have created AutoOps a culture in terms of they have created a lot of remediation actions that automatically force resources to be standardized. Talking about the standardization is they're also using AWS Service Catalog, where the cloud team creates products to be deployed for the projects in a standard way. So all of this thing is for protect for a lot of things, and Luis is going to explain us more about it.
Yeah, I think that we all know we are in a security event, and this is a session about data protection, so let's focus on that. As you have already listened from us, BBVA is in the bank industry, and the financial services industry is a very regulated industry. So in order to be able to protect everything properly, we need to have in mind very clear what assets we have to protect. And for us, our most precious assets are of data, okay? And what is our most sensitive data? Our business and customer information. So in order to protect this data the best as possible, what we have tried to do, the strategy that we have applied in this case, is about embedding security in the process of designing all the architectures within the bank. Okay, and I would like just to mention a few key security leading points that we try to follow when we are designing these architectures and embedding security. One of these key points are minimizing the public and private exposition of resources and services in order to minimize the attack surface. Secondly, we aim to control all the outbound connection to the public internet in order to avoid potential data breaches or exfiltration of information through public channels. Of course, we protect data itself with the native capabilities that the cloud provider offers to us. And I'm talking, of course, about encryption at rest, encryption in transit, or some optional features such as transparent data encryption, for instance, right? And last, we have to know that the attacker is not always outside of the organization, but it is sometimes inside of the organization. And in order to deal with this risk and minimize it as much as possible, what we try to do is to segmentate the permissions and the networking within our on-premise and cloud facilities in order to ensure that the users only access the network contexts and resources that they are required to access to, and not anything else. But I always say that the best way of understanding these concepts or anything else is by taking a look at an example of it. So let's take a look at our AWS networking model. This is basically a networking model that serves as an extension of our on-premises data centers, right? The idea that we have tried to apply in this model is based on the idea of a public and private part. And trying to follow this concept, we have designed the VPC we have divided the VPC into two types of subnets. Let's start with the public subnet. And you'll be wondering, public subnet, does it mean public in terms of internet connection? The answer is no. When we say public, we mean public within our data center that is visible or accessible from other accounts that follow this networking model or from the data center itself. Okay. So, in this public subnet that we will call from now on interconnection subnet, just to avoid the confusion, this is where we would deploy all of these services and resources that allows us to perform two main tasks. The first one is being able to expose services, to screen services. And the second one is providing the capability to navigate from the inner part of the VPC to the outside, to consume other services that are offered from different AWS accounts or the on-premises data center. And the services that we used to achieve these functionalities are, of course, elastic load balancing and private NAT gateways. And on the other hand, we have the private subnet, which is the typical private subnet that we would find anywhere. I'm talking about a subnet with a CIDR 10/8 or 10/16. And in this subnet, we would deploy all of these resources that we need to isolate and protect from the outside. Okay, I'm talking about databases, instances, Lambdas, even SageMaker Studios or AppStream fleets, as you will see later. In this subnet, we deploy as well networking elements that allow us to go from in a private way to third-party APIs. For example, for consuming our internal BBVA proxy that allows us to navigate through the internet in a controlled and safe way. And a different case, navigating to AWS APIs that allows us to go to these AWS APIs in a safe way as well. In this model, we have as well two networking elements that allows us to control the traffic. The first one are the network ACLs that allows us to control the traffic inside of the VPC and the communication between the outside and the inside. And secondly, and this is more recent, we have deployed the AWS network firewall in order to perform inspection of the traffic and control the east-west traffic as well. But in this architecture, not everything is perfect. As we were using it, we started having some challenges and use cases that required special attention in order to comply with the request that the projects were requesting to us. Starting in 2019, we started having a couple of requests that are very similar. They requested us to connect, to administrate internal resources, and these resources are typically databases and internal and third-party products. The truth is that back then we already had a Bastion host that offered this kind of connection by using an SSH interface and command line clients. But I think that most of you will agree with me that when you are managing databases, data, and this kind of resources, command line interface clients are not the most productive tool to perform that task, right? So what they requested us to do is to offer them a way to administrate these resources by using graphic user interface clients. So we had to find a way to achieve that. And a bit later, at the beginning of 2020, you all remember the COVID-19 pandemic. Almost all of us had to start working from home. And a big part of our employees needed to access to some internal services on a daily basis. These internal services were critical enough to not being exposed to the internet, and the VPNs that we had by then weren't scaled up very well to the number of employees that we had to provide access to these internal services. So we had to find more creative ways to provide this access to these services. And a bit later, during 2023, last year, as Jose has mentioned, the data platform started the migration to AWS, right? And during this migration or this design, we started having on the table a couple of use cases that we had to deal with. The first one had to do with accessing reports that are exposed typically on a web page or a server by an URL, okay? But these reports contain sensitive information. So we had to find a way to let them access these reports without putting into risk the information that it exposes. And the second use case that we found during this migration was related to the way this data platform has been built on AWS. As Jose mentioned, this data platform has been built on AWS using managed services. So the developers and data scientists that are required to access to, for example, SageMaker Studios or the AWS Management Console, Athena, S3, and these kind of services, they're required to access to these development environments. But in these development environments, we could find sensitive data, customer information. So the idea was to give them a way to work and build their models, their analytics, using this sensitive data without putting into risk this data and avoid potential breaches. I think that you all know that we are in an Amazon AppStream session, so you'll know that the solution that we found for all of these challenges and use cases was, of course, Amazon AppStream. We believe Amazon AppStream is a very good solution in terms of isolation, security, and in virtualization of applications in order to provide access to these resources to our users. But we also think that there are, once we started analyzing the service, we found that we had to deal with some issues before using the service at scale. The first issue that we found was related to the streaming URLs that are used to access to the AppStream sessions. These streaming URLs, if any user within BBVA could create these streaming URLs, this user could potentially share these URLs with whoever they want, and then whoever they want would have access to our resources and our data. So that was a risk that we could not afford, okay? And, well, the second challenge that we found was related to the integration with our identity provider. This is part of our strategy. We state that every application within BBVA has to be integrated with our identity provider. And the truth is that back then, AppStream supported some integration methods with different IDPs, but back then, our IDP didn't support the methods that AppStream supported, and the number of integrations that we would have been forced to do in order to integrate with our IDP would be too high, and it wouldn't scale very well. So we had to find a different way to create this integration without these scaling problems. And finally, the third and fourth challenges that we found regarding Amazon AppStream are related both to the same functionality, and I'm talking about the Amazon Session Context functionality. For those of you who don't know this Session Context functionality, this Session Context feature is a native feature that AppStream offers to you to pass information inside the AppStream session. It's like a way to pass some init context to not make the user sign in again from within the AppStream session every time the user accesses to this session, right? And we found two issues regarding this feature. The first one is that, as everything, it has a limit, a content limit. And the kind of information that we were about to pass inside the AppStream session is basically credentials. And credentials, they are especially long. And we reach this character limit with session context. So we had to find a creative way to pass this information without losing part of the message in the meantime. And finally, the last issue that we found regarding session context is related to the way this session context information is passed into the session. We found that this information travels in the URL, in text clear. So if we wanted to pass credentials inside the AppStream session and not offer this information to the user itself, it's not a good way to do it this way directly. So we had to, as well, look for a solution for these two problems and maybe solve both of these issues at once. So at least for the first two challenges, we decided to develop an internal piece that we call Heimdall. And you'll be wondering, what is Heimdall? Heimdall is basically a global and central entry point for all the fleets that BBVA has, over 100 fleets right now. It performs the integration with our identity provider, and it performs the authorization as well, controlling whether the user has access to the fleet that is requesting access to. We talked before about segmenting and controlling the access to others' resources internally, right? In addition to this, Heimdall also controls the configurations of the AppStream fleets and stack in order to avoid potential breaches by using native functionalities that AppStream offers. But I think the best way of understanding what is Heimdall is by taking a look at a very high-level architecture diagram. Let's start at the left of the picture with the internal user perspective, which is basically an employee. Okay, the employee would access to the Heimdall URL service, which is as well exposed through our DM set. Okay, once the request goes through the DM set, if everything is okay, then the request is accepted, and then it is forwarded to a different account or security pass account where we deploy almost all of our security services, and the request is in the end forwarded to our security API gateway. And this API gateway is a bit special because it offers you the possibility to integrate with our identity provider in a totally transparent way. So that's the way we use this security API gateway. We integrate our application with the identity provider, and then the request is forwarded to this identity provider, so the user performs the authentication if the user doesn't have a valid session already, or if he has a valid session, then the request is accepted using the actual session. So when the user performs this sign-in, and by performing this sign-in, the user it may be requested to perform two-factor authentication, biometrical authentication, and this kind of authentication measures and policies. The identity provider is integrated as well with our identity manager and our LDAP. And in this case, what we try to get is the groups of this user in order to know the groups that is member of. And all of this information, once it is achieved, goes back to the security API gateway and is forwarded to the backend, which is, in this case, yes, it is received by Heimdall. And Heimdall, the main purpose that Heimdall serves at this point, in this version 1, is to perform authorization. So Heimdall checks the requested fleet and checks the groups that has been retrieved from the LDAP. If there's a match, then the request is accepted, and Heimdall proceeds to create a session for this for the requested fleet in the fleet. Okay, but you will have noticed already that the AppStream fleets are not located in the same account as Heimdall is. How can we solve this? Do you know any solution? I know you can't answer me, so I'll answer for you. As you will have noticed, the AppStream fleets are, of course, in AWS, and AWS offers us a very good way to change and jump between one account and the other. what we did was to deploy roles along with these upstream fleets in these accounts, and these roles are only assumed by Heimdall, and by using these temporal credentials, Heimdall creates this streaming URL and redirect the user to it. But in this approach, not everything is perfect. The truth is that Heimdall supported the session context feature that I talked to you about before, but it wasn't being used. And the main reason it wasn't being used is because of the issues that I talked to you about like 5 minutes ago. As we exceeded the limit of the session context, we wouldn't be able to pass the whole content that we wanted to pass into the upstream session. And for some cases where the content would be sensitive, we couldn't afford to pass that kind of information through this feature because the user would have access to it and it wouldn't make any sense. So we had to think of a solution for this problem, and this is when we decided to develop an extension of the Heimdall version 1, and the name of this extension is what we called the Heimdall single sign-on architecture. First, I would like to explain you the idea that is behind this architecture. The idea is to keep using the session context functionality, but not pass the content through this functionality. What we do is to store the session content information, the credentials of the user, somewhere else. And what we do is to use the session context functionality to pass a pointer, a reference to that information stored somewhere else, okay? That's the main idea, like we would do in a CPU memory context where you work with memory addresses and this kind of situations, right? So let's start with this flow, what the architecture experiences. The user has to provide his or her session content, the information that we want to pass into the fleet, somehow to Heimdall. And this is the first step. You'll be wondering how this is actually done. The truth is that the user provides this information without noticing it, because we use SAML integrations with our identity provider, and these integrations are transparent for the user. The user doesn't realize. And we receive at Heimdall this information. And we want to ensure these credentials are as much secure as possible. And to do so, the first step that we do is to encrypt this information. And we do that by using a dedicated KMS key. So we perform this call to the KMS service, and we encrypt by using this key. So now that we have this user content, these credentials encrypted, what we do is to store them. How can we store them? And what we did in this case was to expose a private API gateway that is located in a cloud security central account that screens all of these single sign-on architecture services, okay? One of these is the store of the encrypted secret, and that's the third step. We store information. But now, we have to find a way for the session to retrieve this information afterwards, right? How can we do that? The way we found to do this was as simple as give the upstream session access to our API gateway. But how can we do that without putting into risk the whole service and the rest of the user's credentials? What we did was to provide them access for as long as it is required. And I'm talking about providing them a one-time use API token, which is the minimum required actions that the session needs to perform in order to retrieve the secret content. And that's what we did. When we store the secret, we retrieve as well a one-time use token along with the secret ID, the reference to the secret. And how can we pass this information inside of the upstream session? Do you know how could we do that? Of course, we use the session context functionality that AppStream offers to us. We put this secret ID and API key inside this session context, and we pass that information into the upstream session. So at this point, the information has been passed into the upstream session. How can this session retrieve the information automatically without making the user to perform any actions? The answer is as well offered by AppStream natively, and what we do in this case is to use the AppStream session scripts, and to be more specific, the start session script that is executed every time a session is started. So we just have to program this script to perform a call to this API gateway using the session context that we passed as input, and that's it. It performs the call and the secret is retrieved. But if you recall, we encrypted this content at the beginning. So this script has to decrypt information, and what we do is to provide them access to the very same API KMS key that we used to encrypt it at the beginning. And now the last step that this script has to do is basically open a browser with this information, like assigning URL or initialize a product inside of the session or something like that. But now that you've seen this flow, let's take a look at how it is the architecture in reality, how it is after this screening API gateway. And now I would like to start from the left at the left of the picture, where you can find Heimdall and the AppStream fleet, or let's talk about this session, okay, the AppStream session. As you can see, there are two VPC endpoints on both parts. One is for accessing the API gateway service, and the other one is for accessing the KMS service. These VPC endpoints are really important for us because they are used as origins. We use them to profile our resource policies and restrict the origins of the requests that can be made to our resources, keys, and API gateway, right? And let's talk about where we store the user's credentials. We decided to store them in a DynamoDB table. You may find that at the right of the picture, the single sign-on table. This DynamoDB table stores the encrypted secret and has mainly two security measures. The first one is that it is encrypted at rest, and you'll be wondering what's the deal about it. And DynamoDB already encrypts at rest by default. What we did in this case is to encrypt this table at rest by using another dedicated KMS key. And what we do is to configure a resource policy in this KMS key to allow only the encryption and decryption of the data to the roles that are assumed by the lambdas of this architecture. This way, an administrator of this account, for example, me, I can't get into that table, and when I try to list and get the items inside this table, the only thing I get is an access denied. This is the first security measure. But the second one is that it's about the thing that we don't want to store these user credentials forever, just for as long as it is required for this process to work. And this process usually takes between 1 and 3 minutes in the worst of the cases, okay? So what we did in this case to store them for as long as it is required is to use another DynamoDB native feature that is time to live feature. What we did was to enable this and set the time to live of these items for a maximum of 5 minutes. This way, we don't have to manage this life cycle of these credentials. Now, I would like to talk to you about the one-time API key that we pass to provide access to the session to retrieve the secret, right? The thing is that we didn't use the native API keys that API Gateway offers. And the main reason is that the way we create and delete API keys is too fast, and the API keys are not available so soon after being created. It takes a bit longer. And this is why we were forced to build our own and custom tokens. And we did this by using Lambda Authorizer and another DynamoDB table, where we would store these tokens. This DynamoDB table has similar security measures as the other one, and the Lambda Authorizer would authorize every request that is performed to this API gateway and checks in the table whether it's a valid token or not. To end with this slide, I would like just to mention that this architecture has every security measure that AWS offer to us. every role, every Lambda has its own role with its own permissions with a very fine-grained level. We are following the principle of minimum privilege on every element. Every resource that supports resource policies is being configured to ensure the minimum access as possible. And, of course, as I said at the beginning, we are using these VPC endpoints as origins to ensure that the request may only be done through these VPC endpoints. And finally, even the upstream fleet has a dedicated role that is used to authorize as well as identity, okay? But I think the best way of seeing all of this in action is by taking a look at a demo. And before starting the demo, which is previously recorded, I would like to explain to you what you're about to see. What we are about to do is to access to an upstream fleet, like if I was like a data scientist accessing to the AWS Management Console, okay? For example, the Athena console. So what the user is about to do is to use the handle AWS single sign-on URL. And in this AWS single sign-on URL, we need to provide a few parameters as input so Handle knows where to assume the role and where the user wants to go, okay? The first parameter is, of course, the fleet that the user wants to access to. As I said before, we've got over 100 fleets, and the user has access only to 1 or 2 fleets at most, for example. So we define the fleet, and secondly, we need to specify the account ID and the role that the user wants to use within the upstream session. So that's another information that is required. And finally, there's another parameter that is totally optional, that is a starter URL. And in this case, as I said, we are going to access to Athena by default, okay? So let's see it. As you can see, the user is about to put the AWS single sign-on URL, the upstream fleet, the account ID, the role that he or she wants to use within the fleet, and the Athena URL. Now, we are going to see that the request is forwarded to Handle, the IDP, and right now, highlighted, what you can see is the session context content. If you recall it right, I explained to you that the content that we put in the session context functionality travels in text clear, and for a brief moment, the user is able to see this content. And what the user sees in this case is basically the secret ID and the one-time use API token. And the question that I ask to you is that, do we care if the user has access to this information, to these 2 parameters? For us, the answer is no, we don't care, because this information is useless for the user. First, the API gateway is not accessible for those users. And even if they could get to those API gateways somehow, they need as well AWS credentials, roles credentials, in order to access to this API gateway. So even if they could do that, the only thing that they would get is an encrypted secret. They would need access as well to the key to decrypt it properly. So in the end, that's something that I think it's impossible to happen. And of course, as you can see, the application loaded and it is inside the Athena web page, and the user could navigate to other web pages as well, like for example, the SageMaker Studio and these kind of applications. So in the end, this session is about data and protecting data. But in the end, how are we protecting data itself? Well, the first measures are around upstream. As Jose said in the beginning of the session, we are restricting the configuration of bidirectional copy-paste, like copying from the remote session to the local session, download files, printing files. All of this is totally blocked by Handle, okay? But the user actually needs to navigate to the internet from within of the upstream session. You've seen how the user navigates to the Athena web page. How can we do that in a safe way? What we do in this case is to use a proxy with an access list domain, okay? But you will think that maybe there are other ways to access to these development environments and access the data itself to be able to use them or exfiltrate them, right? But what we did in this case to avoid this is to profile the roles very well and block the assumed role of these roles. I mean, it may only be assumed by handle. Therefore, if the user could get, for example, a SAML assertion from outside of this process, the user could not perform an assumed role with SAML from outside because they are not possible to be assumed outside of handle. And finally, the cloud environment, as you know, changes very quick and offers like managed services that are something like backdoors. And I'm talking, of course, of Amazon S3, for example, which is where we store part of our sensitive data as data repositories. You know, these S3 buckets that we have are private, but you know that private in terms of authentication, in terms of networking, they are actually public. So if anyone from the inside would want to share the data from the inside of the bucket by changing the resource policy, it could be possible. It's a potential scenario. So what we did to reduce this risk as much as possible is to configure resource policies in these data repositories to restrict the access to these data repositories. And in order to ensure that these resource policies are not modified afterwards, what we did was to perform continuous auditing of these resource policies. To finish this session, I would like to talk to you about the next steps that we are working on right now. The first one goes around the Amazon regions. As I said at the beginning, we aim to be as close as possible to our customers and our internal users. Right now, our upstream fleets are in North Virginia and Ireland because they are not available yet. The upstream service is not available yet in Spain. And what we are expecting is the enablement of this service in Spain to migrate these upstream fleets to this region and improve the user experience by reducing the latency and increases the performance when connecting to the resources that are actually in the Spain region. The second case that we are currently working on has to do with performing changes on the upstream fleets, in the production upstream fleets, without putting into risk the service, the sessions that are actively in these upstream fleets. And in order to solve this problem, the strategy that we are trying to follow is performing blue-green deployments. We don't actually know if the upstream product team is working on this feature, but as we need this right now, what we are trying to do is create like blue and green fleets and change the pointer from one to the other when performing changes. And this way we may avoid session losses and this kind of shortages. And finally, the last use case that we have on the table and we will work during the next 6 months is related to a new tool that we are trying to deploy within our facilities that serves as a product to administrate other products. Okay, it's an application to administrate products. And in some cases, the access that is achieved by using this tool contains sensitive information. So what we try to do in this case is just to embed this application inside Amazon Upstream fleets and offer the access through Amazon Upstream and then administrate the inner part through this tool. Thank you very much. This was everything, and I hope you like this session.
Thank you so much for being here.